Imagine a universe smaller than an atom, unimaginably dense and hot. Then, imagine it exploding outwards, expanding and cooling, eventually forming the stars and galaxies we see today. This is the essence of the Big Bang Theory, our best scientific model for the origin and evolution of the universe. Around 13.8 billion years ago, this dramatic expansion began, marking the birth of space and time as we know them. As the universe cooled, elementary particles formed, eventually giving rise to atoms, stars, and galaxies. The evidence for the Big Bang is compelling, from the redshift of distant galaxies to the cosmic microwave background radiation, a faint afterglow of the Big Bang itself. The Big Bang Theory is a triumph of modern cosmology, but it leaves us with profound questions. What existed before the Big Bang? What caused this cataclysmic expansion? The quest to answer these questions pushes the boundaries of our understanding and leads us to explore some of the most mind-boggling concepts in science. The very notion of before the Big Bang presents a conceptual challenge. If the Big Bang marked the beginning of time itself, can we even talk about a before? Some physicists argue that the question is meaningless, like asking what lies north of the North Pole. However, others believe that the Big Bang might not have been the absolute beginning, but rather a transition from a previous state. Perhaps our universe arose from the collapse of a previous universe, a cosmic cycle of expansion and contraction. Or maybe our universe is just one of many universes, each with its own unique properties and history. These ideas, while speculative, are grounded in theoretical physics and fueled by the desire to understand the ultimate nature of reality. They challenge us to expand our imaginations and consider possibilities beyond our current understanding. The Cyclic Model offers a captivating alternative to the traditional Big Bang narrative. This model proposes that our universe goes through endless cycles of expansion and contraction, with each cycle culminating in a Big Bang-like event. In this view, the Big Bang wasn't a singular event, but rather a recurring phase in the life of a much grander, cyclical cosmos. One compelling aspect of the Cyclic Model is its potential to explain certain cosmological puzzles, such as the remarkable uniformity of the cosmic microwave background radiation. This uniformity suggests that regions of the early universe, now vastly separated, were once in contact. The Cyclic Model proposes that a period of contraction before the Big Bang could have provided the necessary conditions for this uniformity. While the Cyclic Model faces its own challenges and requires further theoretical development, it offers a tantalizing glimpse into a universe potentially far older and more intricate than we ever imagined. The idea of a multiverse, a vast collection of universes existing alongside our own, has captured the imaginations of physicists and science fiction writers alike. While the concept might seem like something out of a science fiction novel, it arises naturally from several theories in modern physics, such as string theory and inflationary cosmology. String theory, for example, suggests that our universe is just one of many possible universes, each with its own set of physical laws and constants. Inflationary cosmology, which describes a period of rapid expansion in the very early universe, predicts that our observable universe is just a tiny bubble in a much larger multiverse. If the multiverse exists, it would have profound implications for our understanding of the cosmos and our place within it. It would mean that the laws of physics we observe are not necessarily universal, but rather just one particular set of rules in a much larger cosmic tapestry. Section 5. The Fabric of Reality String Theory. String theory, a leading candidate for a theory of everything, offers a radical reimagining of the fundamental constituents of the universe. Instead of point-like particles, string theory proposes that everything is made up of tiny, vibrating strings. Just as different vibrations of a violin string produce different musical notes, different vibrations of these fundamental strings give rise to the different particles and forces we observe. One of the most intriguing aspects of string theory is its prediction of extraspatial dimensions beyond the three we experience in our everyday lives. These extra dimensions, curled up and hidden from view, could hold the key to understanding the nature of gravity and the unification of all fundamental forces. While string theory remains a work in progress, and experimental verification of its predictions is extremely challenging, it offers a compelling and elegant framework for understanding the universe at its most fundamental level. Section 6. Cosmic Background Radiation, a message from the past. One of the most compelling pieces of evidence supporting the Big Bang theory is the cosmic microwave background radiation, or CMB. Discovered in 1964, this faint afterglow of the Big Bang permeates all of space and provides a snapshot of the universe as it was just 380,000 years after the Big Bang. The CMB is remarkably uniform, with a temperature of just 2.7 Kelvin, which is minus 455 degrees Fahrenheit. This uniformity, along with tiny temperature fluctuations, provides crucial information about the early universe, such as its composition, density, and expansion rate. Studying the CMB is like looking back in time to the universe's infancy, allowing us to piece together the story of its evolution and refine our understanding of the Big Bang. Section 7. A universe from nothing. Exploring the quantum vacuum. The concept of a universe arising from nothing is a perplexing one, challenging our intuitive understanding of cause and effect. However, in the realm of quantum mechanics, the rules governing the subatomic world, the notion of nothing becomes surprisingly nuanced. Quantum mechanics tells us that the vacuum of space is not truly empty, but rather a seething sea of virtual particles, constantly popping in and out of existence. These fleeting particles, governed by the uncertainty principle, borrow energy from the vacuum for brief moments only to disappear back into the void. Some physicists speculate that our universe might have originated from a quantum fluctuation of this vacuum, a spontaneous emergence of energy and space-time from a state of nothingness. While highly speculative, this idea highlights the radical and often counterintuitive nature of quantum mechanics, a realm where our classical intuitions often fail. Section 8. The unknowable and the alluring, embracing the mystery. The quest to understand what existed before the Big Bang, to peer beyond the veil of the known universe, is a testament to the boundless curiosity of the human spirit. While we may never have definitive answers, the journey itself is filled with wonder and the thrill of exploring the unknown. The very act of questioning, of pushing the boundaries of our understanding, is what drives scientific progress. As we grapple with these profound mysteries, we expand our imaginations, refine our theories, and develop new tools to probe the universe's deepest secrets. The universe, in its vastness and complexity, will always hold mysteries that may forever elude our grasp. But that's okay. It's the pursuit, the relentless quest for knowledge, that enriches our understanding and pushes us to explore the cosmos with open minds and a sense of adventure. Section 9. Continuing the quest, the enduring power of human curiosity. The search for answers to these fundamental questions about the origin and nature of the universe is far from over. New telescopes, both ground-based and space-based, are being built to probe the cosmos in unprecedented detail, collecting data that will help us refine our theories and test our models. As we continue to explore the universe and its mysteries, we must embrace the unknown with a sense of wonder and humility. The universe is far stranger and more awe-inspiring than we can imagine, and every new discovery opens up new avenues of inquiry, pushing us to ask even deeper questions. The quest to understand the universe is a journey without end, but it is a journey worth taking. For in seeking answers to the universe's most profound questions, we gain a deeper appreciation for the beauty and complexity of the cosmos and our place within it.